Hello, welcome to Mathematics with D, and today we're going to be finding the area between two curves. This is problem 9 of homework 4 of Math 2000 and Challenge, aka Calculus 2, aka Integral Calculus. Now we're going to have to integrate to find the area between two curves, and these curves are x cubed minus x squared minus 8x and negative x squared plus x. X cubed minus x squared minus 8x is represented in this graph here, and negative x squared plus x is represented in the graph here. When integrating to find the area between two curves, you integrate with the top curve minus the bottom curve. Now in this instance, the positions of the curves switch, so we're going to be finding the integral of bounds -3 to 0, and then adding it to another integral for 0 to 3, which is where they intersect and where they change places. So let's begin to, I almost forgot, we're going to be adding those two values to find the area of these two shaded regions added together. Now let's begin. First, we're going to be integrating between the bounds of -3 to 0, and x, during this portion of the graph, x cubed minus x squared minus 8x is above negative x squared plus x. So I did x cubed minus x squared minus 8x minus negative x squared plus x, which is plus x squared minus x dx. We are going to integrate it by using the opposite of the power rule. We're going to be adding 1 to the exponent of each variable and then dividing by that new exponent. So in this case we have x cubed. We're going to add 1 to 3 and divide it by that same value. So we have x to the 4th over 4, and we do the same thing throughout this problem, throughout this integral. So we have x squared goes to x cubed over 3, 8x goes to 4x squared because it was x to the first power. Add 1, we've got x squared divided by n plus 1, which in this case is now 2. 8 divided by 2 is 4. X squared goes to x cubed over 3, and negative x goes to negative x squared divided by 2. And we're going to be integrating this with the bounds -3 to 0, and that value is 20.25. Now we're going to be finding the integral of negative x squared plus x minus x cubed minus x squared minus 8x from 0 to 3, because this is where they switch positions, and negative x squared plus x is above x cubed minus x squared minus 8x. And we're going to be using the opposite of the power rule again by adding 1 to the exponent of the variable and then dividing by n plus 1, which is the new exponent of the variable. And in this case we have negative x squared becomes negative x cubed over 3 plus x goes to x squared over 2, negative x cubed goes to negative x to the 4th over 4 plus x squared goes to x cubed over 3, and then 8x goes to 4x squared, and all that is going to be integrated with the bounds 0 to 3, and we get 20.25 again. And now to find, this is the area of the individual parts of this function. So to find the total area of these two, we have to add both of the areas of these individual bounded regions together. So we get 20.25 plus 20.25 equals 40.5. And that is how you solve the problem.